Good morning. I welcome you all in this new session. Today I am going to discuss the last part of the statistical thermodynamics, that is application of statistical thermodynamics, and particularly I will concentrate on the partition function. And you know that partition function is just like if I consider the quantum mechanics, the importance of the wave function. Similarly, if you know the partition function, so you can determine all the thermodynamic parameters very accurately. So, because there are so many thermodynamic properties, starting from internal energy, average energy, entropy, free energy, enthalpy. So, what I am planning, today I will discuss only two properties first. One is molecular energies, and then heat capacity at constant volume. Now, what is the importance or the beauty of this partition function is that if you understand the concept of the partition function and if you derive internal energy or average internal energy or molecular energy, so you can derive all the thermodynamic functions. So, although in my first series of statistical thermodynamics, I have already prepared large number of lectures related to partition function, different types of the partition function, rotational partition function. So I will not repeat all those things. And as usual, you know that as a M.Sc second semester chemistry student, you must refer the most common physical chemistry book, like P.W. Atkins physical chemistry or Irian Levine physical chemistry, or even Albert E. Daniel and G.M. Barrow. बट कभी कभी स्टूडेंट्स को थोड़ा सा कंफ्यूजन हो जाता है कि हमें कौन सा बुक को पढ़ना है, बिकॉज यू नो दैट डेरिवेशन इज वेरी सिंपल, बट sometimes you will find different notation. So, for example, if you refer the very famous book Atkins, you will find that they generally refer the partition function is small q or capital Q. And if you consider the Levine, you will find small z and capital Z. Small q is the molecular partition function and another is the capital is the molar partition function, or sometimes it is called the canonical partition function. तो इसमें कोई प्रॉब्लम नहीं है, आप किसी भी बुक्स को रिफर कर सकते हैं और आप मोलर पार्टीशन फंक्शन भी निकाल सकते हैं, मॉलिक्यूलर पार्टीशन फंक्शन भी निकाल सकते हैं. तो जो मेथड आपको इजी लगे यू कैन टेक. तो जो फंक्शन आपको इजी लगे उसी फंक्शन से उसी बुक से आप कर सकते हैं. जैसा आई ऑलवेज आस्क माय स्टूडेंट टू रिफर दी Thermodynamics for Chemists by Samuel Glaston. It is a very old book, but the derivation is simple. तो मेरा जो आज का लेक्चर होगा वो मैं स्टूडेंट सेंट्रिक एंड वेरी इजी मेथड आपको बताऊंगा. नाउ बिफोर आई go for derivation, you know that generally I use that why we study this partition function, because it is a, of course, most important concept. And if you ask me, sir, can you define this partition function? So it is a distribution of molecules among the different energy levels. So a partition function is defined as a mathematical expression that represent the sum of probabilities of all possible arrangements of the system. I will explain this thing. And of course, always statistical thermodynamics, you know, it acts as a bridge between the microscopic behavior of the particles and of course the macroscopic properties. And you know that macroscopic properties का मतलब होता है जितने thermodynamic properties होते हैं. Now, जैसा कि मैंने आपको बताया कि स्टूडेंट को बहुत बार कंफ्यूजन होता है और उसमें आपको चूंकि यू आर M.Sc आई थिंक थर्ड सेमेस्टर स्टूडेंट, सेकेंड सेमेस्टर स्टूडेंट, तो इसको थोड़ा ख्याल रखिए कि you can, it is up, there is no hard and fast rules, but you please check your question paper and other things whether they are referring the molecular name itself is a definition. Partition function is one molecule and molar, one mole. A system composed of large number of molecules, N1, N2, N3, N4 like that, and they are possessing different types of energy. So if it is a small q, so it is molecular partition function, and there is a relationship between, you know, that if the particles are distinguishable, then of course q is equal to qn, n is the number of molecules divided by n factorial, total number of systems. Or so today I will use small q. Small q मतलब molecular partition function. And मैंने आपको अभी थोड़ी देर पहले बताया, इफ यू रिफर दी एटकिंस फिजिकल केमिस्ट्री आपको Q मिलेगा, आप लेवाइन फिजिकल केमिस्ट्री आपको Z, कैपिटल Z मिलेगा. Therefore, for the student purpose, clarity and novelty, I have written some formula. Now, क्योंकि ये नया नहीं, हमने हमारे पुराने लेक्चर में मैंने बहुत अच्छी तरीके से आपको सब चीज बता दिया हूँ. Now, sometimes what happened, and you also have also discussed the Maxwell-Boltzmann distribution, Maxwell-Boltzmann statistics, everything I have prepared and I have discussed with you. So this formula is not new formula, it is the partition function formula. Okay? Summation of, now there is a term and you all know this thing, sometimes it is called the statistical weight factor or degree of degeneration, because there are different levels. Suppose that different levels का जो energy है, which is very similar to that level. So whenever I write or I include the statistical weight factor, so I must write from I to infinity, whatever it is, level. You see here, level. But if I don't use the G, I just consider different energy states. Different energy states. तब हम यहाँ पे लिखेंगे state. And you know it is the total energy and kV is the Boltzmann constant. Now why actual, if you see the original research papers and other books, so actually partition function is denoted as the Z. एक German शब्द है, just and sum. So therefore it is sum over state. So in simpler terms, it tells how many ways a system can be in a particular energy state, because different molecules having different types of energy. So how the molecules are distributed among the available energy levels, of course, at a particular given temperature. So if you know the partition function, you can determine all thermodynamic parameters. तो इसलिए आपको कंफ्यूजन ना हो, इसलिए मैंने दो तरह से फॉर्मूला दिखा रहा हूं. बिकॉज समटाइम्स व्हाट हैपेंड, ये सारे को हम लोग वन बाय वन करेंगे और एक अगर हम निकाल लेंगे इंटरनल एनर्जी. अब कुछ बुक्स में इंटरनल एनर्जी कैन बी डिनोटेड एज कैपिटल ई, इन सम बुक्स इट इज डिनोटेड एज कैपिटल यू, इन सम केसेस एन एंड के, you know, so kn if I multiplied by, you know, r is equal to k by n. So it can be written as the R. You have already studied the Boltzmann distribution statistics, where generally we use the alpha and beta. So beta is equal to, you know that beta is equal to 1 by kT. So in some cases, suppose some objective type of the questions, what is the formula of the or the relationship between the partition function and internal energy. तो आप देखेंगे देखिए यहाँ पे एक फॉर्मूला मैं ये लिखा हूँ, ऑफ कोर्स ये कांस्टेंट वॉल्यूम होना चाहिए, लिखने में हम भूल गए. And yeah, if I write in the forms of beta, so you see it is different. It is E is equal to minus N d by dB natural log of Q. Q is the partition function here. So here, because beta is, so it is here minus. So don't get confused. Similarly like that. These are different formula. मतलब अगर एक formula को अगर आप जानेंगे, so for example, if I know the values of the E and I have to calculate the CV. Here. Okay, black, red or black. Suppose I want to calculate the CV, molar heat capacity at constant heat, specific heat capacity. So you know that change in internal energy with respect to temperature at constant volume. So what I have to do, I have to substitute the value of this internal energy. I will get this value, R equal natural log. So I have to determine the values of Helmholtz free energy, or G is equal to H minus Ts. So I have to calculate the value of H and S. I can get this. A is equal to E minus Ts. तो मेरे कहने का तात्पर्य यह है कि अगर हम एक फॉर्मूला को निकाल लेंगे और उस फॉर्मूला से कोई भी थर्मोडायनेमिक पैरामीटर और इक्विलिब्रियम कांस्टेंट, and this is the application of partition function. Because most of the students referred some Atkins or Levine, so deliberately I am showing a formula of different thermodynamic parameters from the book of Physical Chemistry by Levine, 6th edition, page number 830. You should always refer the new edition, although I am using the 6th edition. तो आप देखेंगे same formula is like that because they are using Z. So Z, E, E, K, T, then this is the pressure, this is the entropy, this is internal energy. You know that if I want to know average internal energy, so average E divided by N. Average internal energy. K is equal to like that. तो मैं इतना फॉर्मूला दिखाने का मतलब ये है ताकि आप कंफ्यूज ना हो. जिस बुक्स को आप रिफर करना चाहते हैं उस बुक को रिफर करिए, बट मेंशन कैपिटल Z इज इक्वल टू कैनोनिकल पार्टीशन फंक्शन और दी मोलर पार्टीशन फंक्शन, स्मॉल z molecular partition function, small q molecular partition function. Today in this lecture I will determine the molecular energy, average molecular energy or internal energy using molecular partition function. कैसे निकालेंगे? Now you know that we need two important formulas. One is Maxwell-Boltzmann distribution, Maxwell-Boltzmann statistics. And you see, I will explain that why there is a n divided by q. ये आपको दिख रहा है और ये n है, ये आपका बोल्टजमैन कांस्टेंट है. तो एक फॉर्मूला तो ये आपको यूज करना है, दूसरा फॉर्मूला आपको यूज करना है पार्टीशन फंक्शन फॉर्मूला. ये देखिए, अभी थोड़ी देर पहले मैंने आपको बताया कि जब हम स्टेटिस्टिकल वेट फैक्टर उसमें इंक्लूड करते हैं तो हम यहाँ पे लेवल लिखते हैं. समटाइम उनकी एनर्जी अगर इक्वल है, बट हियर आई एम नॉट यूजिंग द जी. So I am just simply write Q summation state I exponential EI kBT. So the population of molecules in different energy levels. There are different energy levels. So total energy is equal to N0 corresponding energy is E0, N1 corresponding energy V1, N2 corresponding energy V2, N3 corresponding energy V3, or like that, Ni to Ei. So I can write E is equal to summation of I to infinite Ni and E. So we need three formulas. Okay. Now let me start the derivation of this. It will take only 5 minutes like that. Very simple derivation. But again, you remember three things. Partition function formula, this formula, and how we get this formula. Okay. So first we know that for main E is equal to summation, or EI you can write that, N E. And we have seen that N I is equal to N0, maybe N1, N2, like dot dot dot. And we know that N0 Ni as per the distribution law. We can write N. If I consider the statistical weight factor, then Z0 exponential minus E0 divided by kBT. I'm going to simple example. Now, because there are a large number of systems, so I can write like that. Every case is N0, G0, G0, E0 divided by kBT, plus I can use another color so that we'll get this thing. N0, G0. Now it is first case is G1, statistical weight factor of the first level, exponential minus E1. Similarly, for second level, I can write white, yellow color. So N0, G0, everywhere it is common. G2, exponential E2 by kB. So what I can do, what I can do, that N I. Now this N0, G0 is common. N0, G0 is common. Summation of Gi, Ei, KBT, and it is from I is equal to 0 to I. So this term, sum, actual distribution of different energy levels, it is actually Q, capital Q. Right. So what should I write? Ni N0 G0. This whole part is the small q or partition function. This q is the molecular, here because I am taking partition function. So I can directly write Ni, I can write a q here, N0 divided by G. So therefore, in normal cases, where I have written here what is our actual formula, N is equal to N0 G0, suppose Gi summation of E, anything like that. So I can write, I should not write summation here. So what I can write like that, N I is equal to here N by Q exponential KBT summation. So first उसमें जाइए, this first page, typing page. हाँ, yes, just a minute. Here, like that. N by Q. This. So again, so now what we are, so what I am getting, summation is not required here. Summation is not required. So when you derive this formula, because we have already written last stage, E is equal to summation N E, isn't it? And from partition function formula, we have derived N is equal to Ni. N divided by Q KBT. Because N0 is by G0 in place of, we have written this. So our second stage is that I have to substitute these values of N in our equation. So it will be this, sorry, this will be E summation N divided by Q, very simple, E I KBT, Boltzmann constant, and E. Or I can write, you can start here. तो आप यहीं से शुरू कर सकते हैं, जैसा आपने पार्टीशन फंक्शन से कैसे निकाला गया, ये एक मैं एडिशनल किया, आपने डायरेक्ट यहाँ से कर सकते हैं. सो व्हाट आई कैन राइट, एन बाहर भी आप लिख सकते हैं एन बाई कांस्टेंट एन बाई क्यू समेशन ई एक्सपोनेंशियल ई डिवाइडेड बाय kb is the Boltzmann constant. In some book you can write energy is epsilon like that. Boltzmann constant kb you can write आप kb लिख सकते हो, but it is a Boltzmann constant. ये आपको याद रखना है. So there is only two steps. First step is you write this, write the values of E from this formula. Now you have to determine energy और एवरेज एनर्जी भी आप निकाल सकते हैं. दिस इज एवरेज मॉलिक्यूलर एनर्जी, एवरेज internal or molecular energy. E, whatever you are getting divided by A. In some books, internal energies can be written as U. In some books, Q के जगह में आप Z भी निकाल सकते हो, small z. आपको. So the last stage is that was a very slight mathematics is required. So now I have to use the partition function. And we know the formula of the partition function is Q is equal to summation. I'm not, of course, you can write GI also, exponential minus GI by KBT, isn't it? I is equal to I from IT. So you can avoid for different things. So I'm getting, now what is my objective is partition function से internal energy का क्या फॉर्मूला निकालता है, बस ये हमारी ऑब्जेक्टिव है. तो चलिए let us solve it. Let us solve it. दो फॉर्मूला ये जो मैं ग्रीन कलर से लिखा हूं इसको याद रखिएगा. इस फॉर्मूला को याद रखना है और दूसरा इस फॉर्मूला को याद रखना है. That's all. So differentiation with respect to temperature at constant volume. You know, this is very simple differentiate chain rule आपको लगाना है. Summation या मैं इसको ऐसा भी कर सकता हूं, समेशन को बाहर कर दीजिए, डी बाई डी टी निकालिए इसके साथ एक्सपोनेंशियल. एनी स्टूडेंट कैन सॉल्व इट. द डिफरेंशिएशन इज वेरी सिंपल. उस कांस्टेंट वॉल्यूम कैसे करेंगे देखिए, उदाहरण यहां दिखा दे रहा हूं. just E by n rule exponential u. So EU du dt. So here is u is equal to minus E kBT. So E and kBT is a constant. So what you can write minus E divided by kBT. Not kB d by dt of, if I write like that, t inverse 1. You know n rule. Nx n minus 1. So minus square like that. Here is also minus. So what I am getting? E divided by kbt square. ये माइनस कहाँ चला गया? ये माइनस और ये माइनस 1 by, तो इसलिए ये नीचे आ गया. और एज इट इज जैसा है, एक्सपोनेंशियल माइनस वेरी सिंपल डिफरेंशिएशन, चेन रूल. सो लास्ट स्टेप, ये दोनों को हमको रखना है क्योंकि इसी से हमको करना है. तो व्हाट आई एम गेटिंग, कैन यूज द येलो कलर. सो हम यहाँ पे लिख सकते हैं डी क्यू, use the partition function dt v. Now summation is also there. Summation is also there. So, summation e kbt square exponential minus ei kbt. So just like this thing. Or what I can do, again it is constant. So 1 by kbt square, what summation e, right, exponential minus ei divided by kbt. So that constant volume like that. So now you see very carefully what is the relationship between these two. First, again I am just repeating these things, that I am getting this value using the summation of E and N, and suppose this is equation 1, this is equation 2, and it is equation 3 at constant volume. So it is a very simple differentiation with respect to temperature at constant volume. तो अब दोनों को बहुत केयरफुली देखिए, ये फॉर्मूला और ये फॉर्मूला. So that part हाँ ये continue try it. हाँ बट ये सब रिमूव हो गया ना, अनडू अनडू अनडू. चलिए ठीक से कर लेते हैं. Okay, again I can do it. So no, don't worry. Again I can write. Just I can again write, no problem. So what I am getting, dq dt, no problem, 1 by kbt square summation e by kbt. So you see that I can write like that, dq dt constant kbt square is equal to summation ei exponential ei by kbt. So what I have to do now, दोनों को देखिए, मतलब ये जो पार्ट है, I can write, if I compare this equation 1, 2 and this is equation 3, so that part, in place of that part, I can write this part. क्या पार्ट था, E बड़ा करके मैं लिखता हूँ, so that आपको समझ में आएगा. E कलर थोड़ा ठीक दिख नहीं जाए. E देखिए ग्रीन से लिख रहा हूं मैं, N by Q, Q is the partition function, summation EI exponential EI by KBT। अब आपको समझ में आ जाएगा। सो अगेन इन व्हाइट कलर, इसका मतलब इसके जगह में हम बड़ा करके लिख रहा हूं, E इज इक्वल टू N बाई Q, और ये जो समेशन के पार्ट के जगह में DQ DT कांस्टेंट वॉल्यूम KB T square. So I have to determine this value of this. Now, so what I will do, देखिए फिर से मैं इसको रीअरेंज करते रहा हूँ। E is equal to KB N, I'm just rearranging this equation, E square DQ Q and DT. So you know that like dx x natural log x, because dx dq and q is not a function, it is a differential equation, whereas natural log x is a function. So what I can write like that, I can write like that, natural log of x, that means dx upon x is equal to natural log of x, and Boltzmann constant into n, because r you know, r is equal to n. K is equal to r by n. So final formula K is equal to RT square, R, from where I get R, KB and N. K means Boltzmann constant, RT square d by dt natural log of Q at constant volume. So this is the final formula of internal energy. Internal energy. But for average energy, average, so E divided by N. So if I just divide it by N, so average energy E bar you can write like that. So K T square, I am talking about the average energy, d by dt natural log of Q. Sometimes we determine the internal molecular energy per molecule, average energy per mole, like that. So again, if I go to my backside original, I think this one. So just you see the final formula whenever I written here. You see, this is our formula. This is equal to K T square d by dt natural log J at constant volume, and other. This I can write like that. Now in other books like that, yeah, N K B T square d by natural log of Q. So N by K is R. So what I am getting, R T square d by dt natural log of Q at constant volume, E is equal to K T square, average energy is K T. So let me just summarize the thing, and in my next presentation, what I will do, I will determine the, why I am taking the deliberately CV, because the formula is d by dt at constant volume. So what I have to do, nothing. I have to use CV is equal to d by dt, and in place of E we know. So if I can write like RT square d by d natural log of T and constant volume. तो फिर हम सीबी निकालेंगे तो सीबी से फिर एंट्रोपी निकालेंगे फिर अलग से इसको नहीं. सो फिर से मैं आपको समराइज कर लेता हूँ सो दैट कि आपको कोई कंफ्यूजन ना हो. दैट फर्स्ट मैं इसको निकाल लिया और अब हम सीबी निकालेंगे. सीबी का भी फॉर्मूला यहाँ पे कहीं पे होगा. ये अब मेरा काम है इस फॉर्मूला को निकालना. दिस विल बी सेकंड लेक्चर सो दैट कि it is very simple. Only thing is that first you need two formula. One is Maxwell-Boltzmann statistics, and in that Maxwell-Boltzmann statistics you have to substitute the value of n, and then because our objective is that determination of internal energy from molecular partition function. So therefore we will write the formula of molecular partition function. We will differentiate it with respect to temperature at constant volume, and then we just equate these two equations and we will get the final equation. Once you get this internal energy, then the second part will be the determination of CV at constant volume. Thank you very much.